Have you ever tried to extract data from an XML file, only to find that not all nodes contain the same variables? It can be quite a puzzle, right? If this sounds familiar, you're in the right place. Today, we're going to tackle how to generate a data frame from XML in both R and Python, even when the data isn't perfectly aligned. I totally understand how frustrating it can be when you're working with XML data and you realize that some nodes are missing information. You're not alone in this struggle. Many people face similar challenges when trying to parse XML files. Here's the specific question we're addressing today. One user asked how to create a data frame from an XML file where not all nodes contain all variables. They provided an XML example with 2 observations, one of which is missing a hobby. Sound familiar? Let's dive into this together and find a solution. So, what makes this tricky? In the provided XML, one observation has 2 hobbies, while the other is missing that information entirely. This creates an alignment issue when trying to convert it into a data frame. We'll break down how to handle this situation step by step. And stick around. By the end of this video, you'll have a clear understanding of how to create a well-structured data frame from XML, and I'll share a bonus tip for parsing additional variables easily. To begin, the user should load the XML data using the XML2 library in R. This will allow us to parse the XML structure effectively. Next, the user needs to extract the names and hobbies from the XML. Since hobbies can be multiple, we will combine them into a single string separated by a pipe character. Now, the user should create a data frame that includes the names and the combined hobbies. We will also handle missing hobbies by using NA. Finally, the user can view the resulting data frame. This will show the names, combined hobbies, and skills, with NA where data is missing. Fun fact, did you know that XML stands for Extensible Markup Language? It's designed to store and transport data, making it a popular choice for data interchange. But parsing it can sometimes feel like a maze. Now let's look at the answers provided by other users. An alternative solution provided by another user suggests using the XML2 and PER libraries in R. This approach dynamically extracts node names from each observation and collapses similar nodes into a single string. It then flattens the list and combines the results into a data frame. The process involves entering each observation, finding and storing node names, and then collapsing similar nodes. Finally, it binds the results into a data frame, allowing for easy parsing of additional variables. That wraps up that answer. Let's move on to another one. One alternative solution in R involves using the XML package. The user suggests converting the XML to a list and then creating a data frame by applying a function that extracts names and hobbies. They also recommend cleaning up the data by replacing empty strings with NA and trimming white space. Another approach uses the XML2 and dplyr packages. This method defines a custom operator to handle missing hobbies and constructs a data frame directly from the XML nodes, ensuring that missing values are represented as NA. Let's check out another perspective from a different user. This user suggests creating a function to handle missing or multiple nodes in the XML data. They recommend using the XPathSupply function to extract values, ensuring that if a node is missing, it returns NA. The function also concatenates multiple values like hobbies into a single string. For the XML2 package, the user recommends finding all OBS nodes and applying XML find all for duplicate tags. This method allows for extracting names, hobbies, and skills while handling missing data effectively. That wraps up that answer. Let's move on to another one. An alternative solution provided by another user involves using Python's pandas library along with the element tree module to parse the XML data. They start by building an element tree from the XML string. Then, they define a function that processes each observation, collecting the values into a dictionary. This dictionary is converted into a pandas series, which allows for joining multiple hobbies into a single string. Finally, they create a data frame from the list of series, resulting in a structured table with the desired columns. Here's the bonus tip I promised. When working with XML, always plan for missing data. This will save you a lot of headaches down the road and make your code more robust. And there you have it. You've learned how to generate a data frame from XML in both R and Python, even when not all nodes contain all variables. If you found this video helpful, please subscribe for more tips and tricks.